This is the video for lesson 4.6, negative and zero exponents. To discover how negative exponents work, we're going to look what happens when we have powers of 2. 2 to the third power is 8. 2 times 2 times 2. 2 squared is 4, and we know 2 to the first is 2. So let's look at the pattern that happens. How can we get from 8 to 4? Well, we could subtract 4. However, 4 minus 4 isn't 2. So let's think of another way. We could say 8 divided by 2 is 4. Let's see if that works here. If we do the same thing, 4 divided by 2, we get 2. So this pattern is going to help us figure out what each of these question marks means. To figure out what 2 to the 0th power is, we're going to take 2 and divide it by 2, so we get 1. Well, how about to get 2 to the negative first? We're going to start with 1, we're going to divide it by 2, and that's really 1/2. Well, if we divide that by 2 again, okay, 1/2 divided by 2, we haven't learned this yet, but you should have learned it in before. We have 1/2, we're going to change it to multiplication, and we're going to flip our second number. Well, our second number, we can say 2 over 1, and if we flip it, it's 1/2. So 1/2 times 1/2 is 1/4. So when we have negative numbers, when we have negative exponents, our numbers are going to end up being in the denominator of a fraction. So let's look at our rule. For any non-zero number a to the 0th power equals 1. So that means you can take any number except 0 and raise it to the 0th power and you get 1. So you can say 4 to the 0, that's 1. You can say 1003 to the 0th power, you get 1. You can say -5 to the 0th power, it equals 1. Okay, so any number to the 0th power, as long as this isn't 0, gives you the answer of 1. Okay, well for any non-zero number a and any integer n, a to the negative n means 1 over a to the n. Now I know that looks a little bit strange, and hopefully once we do some examples it'll make a little bit more sense. But you'll notice that our a ends up in the denominator of a fraction, that n, the exponent, goes with it, and then our negative changes to a positive. So we take 1 over this, but just get rid of that negative. Okay, so I know some of us are probably scratching our heads right now, so let's do an example to figure out what this means. So we're going to be writing these three expressions with only positive exponents. Okay, so we're starting with 3 to the -5. Now what that negative exponent is going to do is going to be to put this in the denominator of a fraction. And whenever we just take a single thing and put it in the denominator, we're always just going to make that numerator 1. Okay, so we take it and put it in the denominator, and that -5 just becomes a positive 5 now. So our answer is 1 over 3 to the 5th power. Let's look at b. We have m to the 0th power times n to the -4th. Well, we're going to do this in pieces. M to the 0th power, we can have anything raised to the 0th power and we get an answer of 1. So really it's 1 times n to the -4th, which is just going to be n to the -4th. So we're going to say, since we have a negative exponent, we're going to put it in the denominator. So n to the -4th, we're going to be put over n to the 4th, and we have 1. So 1 over n to the 4th. Okay, this one here, the only thing that has that negative exponent attached to it is that x. Okay, before, our whole problem had an exponent. That's why the whole problem ended up in the denominator, and we had a numerator of 1. Here we have some things that don't have any negative exponents, so they're going to stay up in the numerator. So we're going to deal with this x to the -6, and we're going to say, hey, let's put that in the denominator. And then on top, we just have our 16y still, since they're not affected by any negative exponents. So we get 16y over x to the 6th. Okay, I know this is new and a little strange, but I want you to go ahead and try and do the 4 checkpoint questions. So pause the video, give it a try, and when you're ready, hit play. Okay, here we have 5 to the negative 2nd power. So that means we're taking it, we're sticking it in the denominator of a fraction. We're going to have 5 squared. So 1 over 5 squared. For b, we have an exponent of 0, so this whole thing, despite being really big as a base, is just 1. In letter C, the 3 does not have an exponent attached to it. That negative 2 is just with the y. Okay, so that 3 is just going to stay in the numerator, and the y's are going to go down to the denominator. So we get 3 over y squared. And in D, the a's are what have the negative exponent, so our b's are going to stay up on top, and our a's drop down to the bottom. So b cubed over a to the 7th. Okay, if you have any questions, please make sure you're writing them down so you can ask tomorrow. And we're going to move on to rewriting fractions. Now it says you can use the prime factorization of a number to write a fraction as an expression involving negative exponents. So up here, I'm going to go back up for a sec. The directions said to take the negative exponents and write them as positives. Here, we're kind of going backwards. Okay, we're starting with a fraction. And we're saying, well, how can we rewrite this without a fraction bar? Meaning, how can we rewrite this using those negative exponents? Okay, and there's a couple ways we can do this one. It says the prime factor, but there's actually a couple different answers you could give me for letter A. If we prime factored 16, we can say that that is 1 over 2 to the 4th. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So we could rewrite 1 over 16 as 1 over 2 to the 4th. Now if we want to get that 2 to the 4th out of our denominator, we can say, let's write that 2 with a negative 4 as an exponent. So no more fraction, and that is the answer. Now could you also say, I don't know, 16 to the negative 1st? Definitely. Okay, so that's another option. You could also say, well, 16 is 4 squared, so you can say 4 to the negative 2nd. So those are 3 different ways you can actually write this fraction. Okay, in letter B, we need to get that c to the 3rd power, that c to the 3rd power out of our denominator. Okay, so our a squared isn't going to be affected at all, but to get that c to the 3rd power out of the denominator, we're going to rewrite it, multiplied to our a squared, but rewrite it with the negative 3 as the exponent. Okay, let's flip our page over. We're going to use our power properties that we learned yesterday with negative exponents now. Okay, so remember when we are multiplying things with the same base, we add the 2 exponents together. When we're dividing things with the same base, we subtract the exponents from each other. Okay, so we need to remember what we learned from yesterday. If you need to take out your notes to help you, then definitely go for it. So here, we have 5 to the 10th times 5 to the negative 6th. We have the base of 5, so we're going to add our 2 exponents together. But you need to remember your integer rules. So I have 10 plus negative 6. Okay, different signs means we really subtract our numbers, take the sign of the bigger number, so we get 4. So that means our new exponent is going to be 4. So 5 to the 4th power. Our directions say to write your answer using only positive exponents. Well, looking at 5 to the 4th has a positive exponent, so that means we're done. Okay, here we have 8n to the negative 3rd over n squared. So right now, we're dealing with these n's because it has the same base. We're dividing them. We need to subtract the denominator from the numerator. So we're going to say -3 minus 2. Well, that would mean -3 plus a -2, which means -5. So now I'm going to write my I'm going to write my 8. I'm going to say n to the -5. You always just want to start by sticking it up there in the numerator. But now the problem is we have n to the -5. That's a negative exponent. So how are we going to fix that? Well, we're going to say let's take our 8, keep it on top, stick our n to the 5th on the bottom. And that is our final answer. Okay, there's a bunch of questions in this checkpoint, but they should go fairly quick. Okay, so pause the video, give them a try, and then hit play when you're ready. Okay, number 5, 1 over 25, we can rewrite as 1 over 5 squared. So one possible answer is 5 to -2 to get rid of the fraction, or we can say 25 to the -1st. Either answer is acceptable. Here we can say 1,000 to the -1st, or 1,000 is, oh, I think that might be the only way we can do that one. Okay, so 1,000 to the -1st. Number 7, we have 2 over a to the 8th. Well, we need to get that a to the 8th out of the denominator. So we have 2a to the -8. And finally, we need to get z squared out of the denominator. So our x to the 7th stays the same, z to the -2. Number 9, using our power properties. Okay, we're multiplying, same base of 3. Let's add those variables together. Sorry, add those exponents together. -7 plus 11 is 4, so our answer is 3 to the 4th. -8 plus -7 is -15, so we get 5 to the -15th power. However, we have that negative exponent, which we don't like, so that means 1 over 5 to the 15th. Over here, multiplying with base m, we have -3 plus a -1, which would be -4. So that means it's m to the -4th power. But once again, negative exponent u, we flip it into the denominator, put our 1 on top. 1 over m to the 4th. Over here, -2 plus 10 is 8. So it's going to be a to the 8th power. Positive exponent, we're good. Okay, 13 through 16, we're dividing, so we need to subtract our exponents. So I have -3 minus 4, always numerator minus the denominator, which would be -3 plus a -4, which gives you -7. So it would be 2 to the -7th power. But to get rid of the negative, put it in the denominator, 1 over to the 7th. Number 14, we subtract our numerator exponent minus our denominator. This really means to add the opposite, so we get 10. So our answer is just 7 to the 10th power. Here we have a 5, but no exponent, so what we're really worried about right now is the k's. So I'm going to say 3 minus -9. That minus negative becomes plus. So the exponent on the k is 12, and we get 5k to the 12th. And the last one over here, -4 minus -6 is -4 plus a positive 6, which equals 2. So b squared. Okay, last example. Geckos can easily climb smooth vertical surfaces. Biologists have discovered that tiny hairs are the reason that the feet of a gecko are so sticky. Each hair is about 100 micrometers long. A micrometer is 10 to the -6 meter. what is the length of one hair in meters? So if we know each micrometer is this many meters long, and we have 100 of them, we can say 100 times 10 to the negative 6, and we can use our power products property here because 100 is really 10 squared. So we're saying 10 squared times 10 to the negative 6. Same base, add the exponents. 2 plus negative 6 is a negative 4. So we get 10 to the negative 4th power. Okay, and we can say 10 to the negative 4th meters. Okay, because in this case it doesn't say to write it without a negative. Or we can also say 1 over 10,000 meters. Either answer is acceptable. Okay, that's the end of this lesson. Once again, please write down any questions. I know this one was slightly different than some things we've learned before. Okay, and we will start off with questions tomorrow and then get to group work.